Hello everybody and welcome to lesson 10 of natural hazards. I can't believe we're on to double figures now. Well done with some fantastic work coming through as always. You may have noticed some parts have been put onto Twitter and Facebook in terms of social media. Really good quality work. Just a reminder though, can you please upload it to Teams as well as doing the quiz? If you've done anything in particular that needs to be put on Teams, some of you are ticking the handed in part and I go and have a look and I see that it's blank. So only put handed in if you've actually done something or you've emailed it to me and told me that you've done that. Otherwise it will get a little bit lost in the system of me thinking you've done something and I can't actually see it. So it'd be great to give some feedback on it. So if you look here, lesson 10, you can see we're doing something on supervolcanoes. Before we do that though, let's have a little recap on some prior learning. So if you have a look, what I want you to do here is a bit of a triangle, and at the very top of your triangle I want you to think of one question that is still in your mind. We've been studying this now for 10 weeks and I want you to think about all the issues, whether it's earthquakes, volcanoes, tsunamis, the structure of the earth, anything at all, and I want you to write down one question that you would still like to know the answer to. And the real challenge is then go and research it. And if you still can't find it, email me that question and we'll see whether together we can work that out. I want you to come up with two terms associated with plate tectonics and give them definitions. Pick two that are a bit of a challenge. I don't know, maybe something like pyroclastic flow, something that you don't normally use in your everyday language. And then three things or facts you've learned about tsunamis previously. Not necessarily just a case study, you've probably all heard of the Boxing Day tsunami, but maybe something about to do with the friction that makes the wave gets higher, something that's going to stretch and challenge you rather than just three basic facts. So put yourself on pause and have a go at doing that as a starter. Okay, so I like this title, Why Are Supervolcanoes Super? What we're going to do is we're going to be able to locate them globally. We're going to explain the causes of supervolcanoes, and this bit here is really important. We're only going to be able to hypothesize about the impacts and responses of supervolcanoes because actually we don't really have them in our lifetime, or haven't had them in our lifetime. We can see geologically speaking that they have existed, but we haven't had an eruption of a supervolcano for hundreds of thousands of years, or a particularly significant one. We've had some major ones, but not any that are going to be classed as supervolcanoes in this way. So we can only hypothesize, suggest what we think might happen in the future. So putting it into context as always as to how this fits into our natural hazard scheme of work. Okay, as you know, we've looked at what makes a natural hazard, looked at the structure of the earth and plate tectonics. We've done all of our work on seismic events, and this here takes us now pretty much towards the end of our work on volcanoes. So once we've done this here, that leaves us with the last part, which is living in hazardous areas. So that's what we'll be moving on to next week, of thinking about why people live in hazardous areas. So we need to know, well, where can we actually find supervolcanoes? So looking at this map of the world here, what you can quite clearly see is we only have 7. 3 of them are on the North American plate. We've got one here, which is just about on the Eurasian plate, but really sort of on the boundary, the margin with the Indo-Australian plate. We have this one, and I'm going to explain this term caldera to you later on, but the area caldera, which is really where a lot of plate boundaries converge over towards Japan. We have this one here in New Zealand, Lake Taupo, and then this one all the way up here in Siberia, the Siberian traps. So those there are our 7 supervolcanoes. One of them you may have heard of before, and that's Yellowstone, and this is the one that we're really going to use as our example today. And if you just have a look here, sorry, my drawings have stayed on this, but if you have a look, you can see on this satellite image where they are as well, so just to give you a better, clearer understanding. And then, as always, we always need to be able to describe the location. So remember, clock the continent, the latitude, so northern or southern hemisphere, any oceans or seas nearby, any countries, and remember the compass directions. And this time, can you also name the plates that they are located on, or the boundaries they're on? So again, put yourself on pause and let's write our description. So that's our first learning objective covered. So let's think about our second one, which is how are they actually formed? So this here is a very simplified diagram. If you have a look here, underneath the Earth's crust, we have got the magma. Okay, so there's our crust and here's our magma. And the rising magma cannot escape, so it creates a large bulge and uplift. What then happens is we've got cracks appearing in the surface, gases come out, and then eventually it collapses after it's exploded. And if I just show you a bit more detail here, this is a much better diagram that really explains it. So if you have a look, we've got a magma chamber forming within the crust. Now it forms over weaknesses in the Earth's crust. These are called hotspots, and they're literally gaps in the Earth's crust where heat can escape. And what happens next is that the growing magma chain forces the ground upwards. So if you have a look, you have this what's called uplift, and you end up with what's called fissures and hydrothermal features. Now hydro, just think for a moment, when we're thinking of hydro, what substance are we thinking of? That's right, water. And thermal is to do with heat. So we're thinking of features such as geysers or geysers. They can be pronounced either way. And the next slide in a minute will have a photograph of one of those. So just wait a moment and I'll show you what one looks like. But they are areas that have huge amounts of warm water being forced outwards. Some of you I know have been to Iceland. Thank you for sending the photographs in of your trips there, and you've seen there the hot springs that appear, so that's a hydrothermal feature. And also in New Zealand they have quite a few as well, and in some places it can be so warm they actually don't need to pay for hot water, because the geothermal heat, so heat from the ground, heats up the water and gives you permanent hot water. So anyway, these here are expanding and expanding, and what happens is that gas and ash escape through these and they cause this super volcanic eruption. And the reason that they are so big is actually they are enormous, and we'll look at the size of one in just a moment. Now the pressure is so great that after the eruption it collapses. Okay, so all that ground that had risen up here is pretty much forced away, and afterwards where the magma has come out there's a gap, so that land there collapses. It's called a caldera, and a caldera is basically, if you think, here's my amazing drawing of a typical volcano, okay, and this bit here is our crater. Now after an eruption the top may be blown away and it leaves with it this wider crater, and what can happen is when a new volcano, when the new magma starts pushing up, you end up with like a miniature volcano appearing inside, and it's just basically the new magma rising up and creating a new volcano in this caldera. Now some volcanoes are just typical mountain sizes, so you see the caldera very, very clearly. If you remember to when I showed you the lesson 2 lessons ago on Montserrat, and on that slide you could see I showed you where the shape of the top of the mountain had completely changed, where the top part of it had blown away through the eruption. Now that will create a relatively small caldera, and you'd be able to visualize it as the new magma comes up, and it will be appearing to form in the crater of the old one. But the thing that's so significant about these examples here is, let me just show you, this here is one of the most famous supervolcanoes, Yellowstone Park. And if you have a look here, you can see how huge it actually is, because if we look at this scale line, there's 0 and there's 10 kilometers. So if we were to measure across there, okay, it's roughly about 40, 50 miles in size. It is enormous, so you actually can't see from one side to the other, and it was actually geologists that were trying to work out this feature. It took them a long time to realise that all of that red dashed line there is the caldera edge. It's so huge, and that's when they realised that there must have been something underneath that was connected, and that's when they found this enormous magma chamber underneath here, and that's when they discovered that there were these things such as supervolcanoes. Now, Yellowstone Park has not erupted for about 600,000 years, and geologists reckon that it erupts about every 700,000 years. So geologists will say that it's actually due for an eruption relatively soon. But in our terms, that's about 70,000 years, which to us, 70,000 years is way out of our timescale. We certainly don't need to be losing any sleep over it, and not an issue. But in geology time, when the world is 4.6 billion years, 70,000 years is kind of like tomorrow. So don't panic, it's not hopefully about to erupt. Although 2020 has been quite an unusual year, so you never know. I am joking, folks, please don't lose sleep. Now, you may have heard of something called Old Faithful Geyser, or Geyser. Again, they can be pronounced either way. And here's a photograph of it. And this here is that hydrothermal event. So underneath that, there is so much heat coming up, and that the layer of water that's got into there is sitting there, and the heat and the gases pressurise it up, and it forces that water up in a huge jet stream. And you can see by the height that it's taller than the trees. Okay, it's hundreds of foot high of the pressure that's building up underneath that, and it pushes it upwards. What you can also see though is not a lot really grows around it, and that's probably because it's probably got a bit of sulphur in it, so it's not a great fertilizer. Okay, now today we're going to do something a little bit different. Okay, quite often I get you to do various activities and worksheets, etc. But that third learning objective was all about hypothesizing what could happen in the future. And there's a film on YouTube, and I hope you can access this and watch it. If you can't, can you let me know, and we'll perhaps try and work out the link or something. But basically, it's just called Supervolcanoes, and it's actually on various platforms on YouTube, but various people have uploaded it. Some have been uploaded into 2 parts, so if for any reason you can't access this one, sometimes you'll see it says part 1 and part 2. It is about 2 hours long. So I'm actually setting you work where I want you to watch what's called a docurama. So they're pretending that it's real, like a drama, but every now and then they'll tell you the facts. And it's imagining that there is this super volcanic eruption at Yellowstone Park. But what's really good about it is it actually talks to you about how it happens. So about this enormous magma dome underneath, and you start to look to see about what warning signs they'll be looking for and the triggers. It also gives you some ideas of what the world would be like if there was to be a supervolcano. An example of such is that there would be so much volcanic ash that we'd have what's called a volcanic winter. It would block the sunlight so much that we would cool down enormously, to the point where crops would fail. People may have to move out of the northern hemisphere down to the southern hemisphere. So, you know, Trump would absolutely have a field day, not because the Mexican wall would have to work the other way round. The Mexicans would probably want it to stop people migrating there from North America because their climate would be too cold. So it's quite an interesting film of talking about what actually happens. But as I say, it is kind of like a drama. It's not a 2-hour documentary, but please watch it and hopefully you'll enjoy it. And when you've finished it, what I want you to do is to carry out maybe a bit of your own research as well, and produce a poster showing me these 3 things. I want to know the location. So remember, these are our learning objectives. I want you to show me on your poster that you know where the 7 major supervolcanoes are in the world. I want you to give me a really good explanation of what causes them. And then I want you to tell me what you think the impacts could be, but also what are we going to do about it? How are we going to respond? Who's going to help one another? Which countries are we going to rely on for support? Okay, so as I say, a little bit different. I've seen such great work that I just thought that this would be something that I'd like you to watch and enjoy, and hopefully just have a think about what supervolcanoes would be like. When you've done it all, as always, there is a quiz. Please remember to hit that submit button. Some of you have been forgetting doing the quizzes and then not hitting submit. what I've done this time is I've actually put some questions in with the supervolcano, but also just a bit of a recap on some of our prior learning. So do have a look at your notes from previous work, because some of the work will relate to that as well. So enjoy the film, let me know what you think about it, maybe ping me an email. Have a good week, and see you ready for next week's lesson. Take care, bye.